Welcome to another series of Talk to the Experts. This is Miriam, Head of Marketing at Barbara. And today we are going to cover Edge MLOps use case with Kike Ramírez, our Senior Solution Architect at Barbara. Hi, Kike, how are you?
Hello, Miriam, how are you? It's so nice to be with you today.
Okay, so what are we going to see today?
Okay, so today what we are going to explain is a use case deployed with the Barbara platform in which we will predict the radiant models in a solar photovoltaic plant. Okay, so let me share my screen and let's go directly to explain the use case. So let me do that. Okay, and here we go. So, what we will see in this use case, we will try to predict the solar radiation in a photovoltaic plant that you may know. Predicting the solar radiation means predicting the energy generation. So this is very important when we are talking about a photovoltaic plant. Okay, and we will use a machine learning model. We have trained to do that. We will get the information of weather station that is available in this photovoltaic plant. And we will use, obviously, the Barbara Edge orchestration platform to deploy all the applications and to create this use case. And we will use only third-party application that will be available in our marketplace. Okay, so what is the architecture of this solution? Okay, so here we have it. As you can see, we will have just one edge node. Okay, this edge node will be located at the solar photovoltaic plant. Here we have the field where we can see this industrial equipment represent the weather station. Okay, so we will be getting the weather information and the weather parameters from this weather station using an OPC UA connector. Okay, we will read it using the OPC UA protocol, and we will be publishing this information in an MQTT broker. Okay, remember, we will always use an MQTT broker to decouple the data generator from the data consumer and to make all the architecture more resilient. Okay, so at the end, what we have is several possibilities or several paths here. In the first path, all the information that it publishes in this MQTT broker will be ingested using this path and using this ingestor to an InfluxDB database, okay? And it will be visualized using a dashboard that we have in this Grafana application. So the first thing, in this application, we will have a dashboard to visualize all the parameters that are in this InfluxDB database. In a parallel way, we have this TensorFlow model here. This is the model we have trained to predict the next hour's radiation using the path values and the weather parameters that we are receiving from this connector. Okay, so this TensorFlow serving is reading the parameters from the broker, making the predictions and publishing them again in the broker. Okay, so everything will be available also here in the Grafana. Then we have three more things. Okay, we have an alert manager tool, which is an application that is available in our marketplace that allows you to monitorize any parameter available, not only in the edge node itself. We can, for example, monitorize the CPU, the RAM consumption, or the temperature of our edge node and set threshold that alert me whenever these variables exceed the threshold. But also any parameters available in the use case. So we can, for example, set some threshold for the irradiant prediction or the energy prediction, and again getting some notification when these thresholds are exceeded. Okay, so this is the function of this alert manager tool. Okay, just alerting when the parameter exceeds the threshold defined. We will also have this ML monitoring tool. This is another application available in our marketplace that allow me to monitorize the behavior of the ML model that I'm using. Okay, so we can connect it to this TensorFlow model we have here in the edge node, and we can check any parameter of the model and the server. Okay, so we can see the behavior of the model, we can see the evolution of the behavior of the model during the time, and we can even set triggers to retrain the model if necessary. Okay, so it is Also very common that whenever you are using a model, you need to make some adjusting from time to time to keep the behavior correct, okay? So this way allow me to monitorize all this information from the model and trigger new retraining whenever it's necessary, okay? And finally, we will have this Azure ingester, another application is available in our marketplace that allow me to get some data from the broker. In this case, I will get the prediction from the models, and I will push them northbound to a cloud, Azure cloud IoT instance. Okay, so I will be pushing this information to the cloud. Okay, so this is the complete use case we are going to see, and if you agree with that, Miren, let's review this in the panel, Barbara panel. Okay. So let's change to this view. Here we have some knowledge node we have with different use cases. Let's check this one because it is the one that is containing the use case we are mentioning, okay? And here we have the applications and models, okay? We have seen in the previous diagram. For example, we have this OPC UA connector, okay, that is getting the information from the weather station, and here we can see in this configuration that we are connecting to this weather station with this URL, and we are refreshing every 300 seconds, every 5 minutes, and we are ingesting this variable, the apparent temperature, the cloud cover, the diffuser radiation is done, etc., etc. Okay, so this way we can get the information and publish it to the MQTT broker. Then we will have a solar radiant model. Okay, this is the model in TensorFlow. We have here the infrared URLs. Okay, so this is where we will be sending the data to get the prediction for the model that will also be published in this MQTT broker. Okay, then we will have the InfluxDB ingester that will put all the information to this InfluxDB database. Okay, we will have the ML monitoring tool to monitorize the model. We will have the alert manager. Okay, here we can see, for example, in the configuration, we are sending, in this case, email, so these recipients, okay, whenever the telemetry, for example, for disk exceed this threshold, or also where these services are down, etc. So we can define in this configuration any threshold we want to include, and we will receive the notification via the service details there. Okay, and finally, we will have this Grafana where we have all the information together. So let's review, in this case, this Grafana, where we can see all the information of the model and the prediction, and then let's review also the ML monitoring tool, etc. Let's start here. We can see the Grafana is available in the port 13,000. So how can I access to this panel? I just need to go here to know the information to my network card and copy this IP. Okay, I will copy it, and then I will open a new tab, and using this port, I will be able to access. So here we can see all the information we are receiving from the weather station. Okay, we can see the temperature at 2 meters. We can see the diffuse radiation, the apparent temperature, the direct normal radiance, etc., etc. Okay, and here we can see, for example, the cloud cover, the temperature at 2 meters, etc. And here in this diagram we have below, we can see the real global irradiant that will indicate the amount of energy that is going to be produced, okay, and also the prediction. So this way we can see, we can compare the real value with the prediction obtained with the AI model. So this way is how we can predict the energy consumption in the next hours. Okay, so this is the panel we are seeing with all the information received from the weather station and the prediction generated by the ML model. But we can see also the monitoring of the ML model itself. Okay, we have this ML monitoring tool. So here is where I can check these parameters of my model. I can see that it has a Grafana. In this case, it's in port 3000. Okay, so again, I will open a new tab. I will use the same IP and I will open the port 3000. Okay, and now I will be seeing not the values of the weather station and the prediction, but the parameters of the ML model itself, okay, and the parameters of the server. So for example, we have here a view indicating the resources consumed by the server. So we can see the CPU, the system load, the RAM, the swap. We have a lot of different parameters here that can be monitored from the server of the model itself, okay? But also I can go back here and I can indicate, okay, I want to check the metric of the T effect. I want to see the solar irradiance model parameters. So this way I can see the number of requests that are being received in this model in the server, the latency quantile, the average latency we have, the load attempts, etc., etc., etc. So every parameter of the model itself is being shown also here. So this is also very important when we are working with AI model. We want to track their behavior and we can do it this way, okay? So now we have one thing pending, okay? I wanted also to mention that we have this Azure ingester that is reading the information we are declaring here. I want to read the information from the weather station and from the solar model ingester that is being published in the MQTT broker, okay? And I want to send it to an Azure IoT Hub with this connection string. Okay, I just need to set here the connection string, so it will read the information from the broker and it will send it to the cloud. Okay, so let me just show you how can we check this. Here I have a Azure IoT Explorer, and I can see that I have here the weather station device. Okay, so I can enter here and I can check the telemetry that we are receiving on real time. So it will start showing the event. As you can see, we are receiving this data with the information of what is being published in the MQTT broker, and it is being pushed into the Azure cloud. But not only that, I can also check here that I have a solar model ingester parameter device that has also a telemetry indicating the values for the irradiance now and the irradiance prediction. Okay, so this is also the information generated by the ML model that is also being published in Azure. So this way we have all the pieces together that get the information from the weather station, make the prediction, store them locally in the edge node to be visualized using a dashboard. Having monitorized also the model, and everything is being pushed to the cloud, to the Azure cloud. Okay. So, well, Miriam, more or less that is the whole use case. What do you think about that? Do you have any question?
Well, good. Yes, I see you're using TensorFlow model. Do you have other options to deploy model at the edge with Barbara?
Yes, that is a very good question. Yes, you have seen that we have here a TF model being served in a TFX server, okay? But we are not limited to this model. One of the good things about Barbara is that in our model library, we can upload any model of the following frameworks, okay? We are compatible natively with TensorFlow, with ONNX, with PyTorch, Scikit, or XGBoost. So you can work with any of these frameworks and you can natively just select the framework you have been using and select the engine you want to use to serve it in your edge node. You can select from TFX, Triton, or MLflow. Then you just need to upload your training model, and that's all. You will have a new model available here that can be deployed in your edge node. But even more, what happens if I am working with any other kind of model? Never mind, because in our marketplace, we have even more solutions. to work with ML model. We have a whole category called artificial intelligence, where you can find different applications that can be installed in the edge node to work with ML model. We have, for example, MLflow. We have also some solution to work with LLM model. We have even compatibility with other third-party application. We have ML server, which is also compatible with a lot of different framework apart from the one we are natively supported. And well, as you can see, there are unlimited possibility to work with ML model using Barbara.
And the model monitoring tools you have shown us, is it compatible with other frameworks?
Yes, and this is a good thing also. I will show you this ML monitoring tool in our marketplace. We have the basic option to work with CPU and the advanced option that is normally used to work with GPU. And both of them are compatible with any of the solution I mentioned before. So whenever you're working with the model deployed in an edge node in Barbara, you can monitorize everything for any option you may have. Okay.
Okay, well, super interesting. Thank you very much, Kike. Thanks to our audience for staying with us. And if you want more information about this particular use case, please follow us. Check it on our blog, on our website, sorry. We have written a blog on this particular use case. So thank you so much to everybody. Until the next session. Bye-bye.
Thank you. Bye-bye.